So this is a talk that I put together, uh, for lack of a better title. I'm calling it the human side of PowerShell scripting. Now, some of you, I'm hoping most of you kind of know who I am and know that I've been doing PowerShell, teaching around about PowerShell since the very beginning. We're almost 20 years now. So I have seen a lot of PowerShell over the years, and I have now, in the latter part of my career, have started moving away from focusing on mechanics to the why. Why do we need to do something? How do we do something in PowerShell? Why are we doing it that way? How's the best way to write PowerShell code for a person to use? And so a lot of this kind of seems like common sense, but sometimes you need someone to lay it out for you and go, oh, yes, I probably should be doing that. Or now I understand why that matters to you. So again, my name is Jeff Hicks. I am a longtime PowerShell MVP and member of the community. The github.io link has links to everything that I do online. So you can find all my social contacts and GitHub repos and all that are all at that link. And of course, we need to thank the sponsors for making this fun little event possible. It's kind of cool moving my little guy around. Not quite as nice as an in-person event, but it's a good substitute, I suppose, these days. So what are we talking about here? Let's start with some PowerShell essential concepts, things that I think everyone should understand. First off, in terms of a critical category, when you use PowerShell, it does not exist in a vacuum. All right. You're not running a PowerShell command that just does one thing. All right. So whether you're running PowerShell interactively or running code, running a script or a function, PowerShell, there's more to it than just the code. It's not just a vacuum. Now, of course, we have AI tools all over the place these days. And for a lot of PowerShell people, especially PowerShell beginners, AI tools are great for generating syntax. I need a function that will do X. That's a great starting point, but you need to be careful that you don't rely on AI to do everything for you, because AI is not a person. And AI, at least in my experience so far in using it to generate code, doesn't fully understand all the things that I'm going to talk about in this session. So an AI tool is great for generating syntax and helping you with the mechanics, but the why you should do things or how you might want to do things, that is a little bit different. And this really brings me to the main point here. There's more to PowerShell, to writing code and using code, than just the syntax and mechanics. PowerShell, for really good PowerShell, it's about the people who are using that code, who's running that code, who needs to maintain that code. And my contention is that better PowerShell code, good PowerShell code, is crafted. It's not generated by an AI. So there has to be a human to touch the code, to put the final touches on it, to make it good PowerShell, great PowerShell for someone to use. That someone could be you, or it could be someone that you are writing code for. It could be end users, the help desk, customers, or whatever. So let's kind of look into this. Now I have a little caveat here. As I'm going through my demos, don't focus on the specifics or necessarily mechanics. Focus on the concepts that I'm trying to show with my code samples. So let's start with code execution or command execution. When you write PowerShell code, there's some things that you need to answer, some questions that you need to figure out. First off, who is going to be using your code? Is it you? Is it the help desk? Is it an end user? What are their expectations? Are they assuming that they're just going to run your code and send it to a printer or send it to a file? Maybe they need to import a CSV and get that data into your function to do something, and then they want to save it to an HTML report. What experience do they have with PowerShell? How much error handling, or how much error handling, for example, do you might you have to take into account if for a newbie versus someone who's really experienced? Oh, I got an error. Yeah, it's no big deal. I can see that I know what I did wrong. Where are they executing the code? Are they running your code interactively in the console? Is it running as a PowerShell scheduled job? Is it running in some CI/CD pipeline where it's completely unattended? How and where and who is using it, those factors will affect how you write your code, or at least they should affect how you write your code. The bottom line should be, how can you ensure that your code will work with as least friction as possible? If I give someone a command to run, I want them to be able to run it with the least amount of effort and have them get a rich result that they can use however they need to in PowerShell. But you have to think about these things. A lot of people just start banging out code, think, okay, I've got to get the mechanics down and the syntax, and I'm done. But that's probably a good start. But there are additional questions and additional features that you might add to your PowerShell code based on the answers that you give to some of these really basic questions here. For example, input. We have a function like this function here, this get drive info, and I need to have the user input a drive letter. Again, don't focus on the function, just think about my concepts here. You do not want to force users to jump through hoops to use your code. So if you can see here, the drive letter is expecting to be something like C:. So if I run my function and it's then going to run get drive info C and then C:\\. So I just get processing and then I get errors because the get some instance doesn't work because the drive letter is not in the right format. So in order for this to work, the user has to know to do C:; or D:; or whatever. And now I can see the processing there and see that works. But I don't want to force the user to have to know what to do, whether they should include the colon or the backslash or not have the backslash. So there are some things that we can do to make that easier. For example, here is another variation on this function. This one includes a couple things here. First off, I just put the drive letter just to be the letter itself, A through Z. And I even have a little validate pattern that will allow me to verify that they're putting in A, B, C, or D, an actual drive letter. Then in the code itself, I'll go ahead and put in and define the drive letter that I need internally in my function. So I'm just have this here appending the colon. I see this a lot in early PowerShell code from people who are just getting started, where they're being quick and dirty and, frankly, I think a little lazy in not taking the time to properly format the input so that it can be used in the function. They're putting all the pressure on the user to try to figure out what they're supposed to do and how they're supposed to use the command. Make it easy for the user to do that. Take away the friction and the pain points. And that's what I've done here. So now when I run this, I can just do get drive info C, and that works. And if I were to test this in the PowerShell console, I would get the validation error too if I used a non-valid error. In fact, let's look at this version of the command. So this version actually takes it a step further. So not only do I have the validation, but I've replaced it actually with an argument completer. I'm not going to go into the techniques of how the argument completer works, but just know that this is a feature that I added to my code sample so that it makes it easier for the user to use. It takes away the pain point or the friction of trying to understand, okay, what value do I put in here? So actually, this I have loaded in my PowerShell session here. So I can do get drive info and hit tab, and you can see it automatically goes through, and now I get the result that I want. And I'm not forcing the user to have to guess what to do. If they put in a valid, there's my warning message that the drive is not found. And actually, I must have an error here in my code. I'll have to fix. So the warning should have shown me the error message or the drive that failed. I'll have to go back and look at that. So don't make the user jump through hoops. Do your job as a PowerShell scripter and add the features so that the user can run your code with minimal effort and minimal stresses. Okay, what value do I need to put in? How should it be? If you can handle that, you should handle it. So continuing on with input, don't assume that the user will enter parameter values the same way that you do when you're writing and developing your code. You have no way of knowing where the user is getting the values that they're passing to parameters. That's why we have parameter validation, and that's why we do things like casting to type. You don't know if someone is importing a JSON file and converting it to an object and then trying to pass that to your function, or a CSV file, or reading some database, or just running some other code that's creating a variable, but you have no idea what's in that variable, and they're feeding that variable into your code. So don't assume anything. Don't assume that the user is going to automatically type in a valid variable value, or I'm sorry, a valid parameter value. You have no idea where they're going to get that information and how they're going to feed it into your function. So here is an example. So I've got this function here. Let me just load this into my notebook here. So this is going to have a function called save data. It needs a path, optional credential, and force, and I'm converting the path. So if I do now try to use this, scroll down here. All right, so I can do get item. So $P is all the directories in the data folder in my scripts folder. And the output gets a little funky here in the notebook here, but it's actually an error. And let's try this. I'm going to paste this into my session here. All right, so I have one directory called data. So $P, oh, so just $P, oh, that's what I'm trying to show here, is $P is null. There are no, clears here. Oop. There are no directories in data. So when I run my function, which is save data, fortunately, you can't correct or account for typos there. Path is, oh, I didn't specify my credential either. Well, this is going great. Oh, And VS Code just crashed. Oh. Well, that's just great. Hold on. Yeah. Let's try sharing this again. Okay. Let's just move on here. I'm not quite sure what's happening here with my function, but let's move on. Point is, you want to make sure that you're taking into the account the unknown or the crazy thing that the user could do. So the other thing that I said at the beginning was when I write code, I want to write it in such a way that I know that the user who runs it will have a high likelihood of success. So this means I need to think about what's the usage scenario? How is someone going to use my function? How can I make my code easier to use? This is where things like aliases, whether we take pipeline input, parameter sets, all come into play. Remember, I said, who's going to use it? How are they going to use it? Maybe the user is the help desk and they're going to read in a computer list of a text file of computer names and feed it into your function in order to get some information and then maybe save it to a JSON file or write to a database or write to another command. So always be thinking about what's the user doing? Where's that data coming from? What are you then doing with it? What's coming out of your function? How is that going to feed the next thing that they might want to use? So these are things that you need to think and keep in mind and will affect the code that you write. So this is an example. It's kind of a slightly weird example because I'm using Active Directory, local Active Directory. So I have a sample function here called backup AD computer that takes a computer name and it will take pipeline input. So if I just run this and just do backup AD computer and the computer name, it works. I don't get any errors. However, how the user might want to use this, they might want to run get AD computer -filter start. So it'll get me all my computers, or maybe they're querying an OU or something, and then they're going to pipe that result to my command backup AD computer. And that will fail because computer name is not a property of the object that get AD computer has. So if I do get AD computer server 1, you can see those are the properties. There's nothing there called computer name. Now, normally in any other situation other than Active Directory, what I would do is create an alias for my computer name parameter, because I don't want to change that because that's the good parameter name. But if I change the alias, if I add an alias to name, then you can see that there's a name property here. When that object gets piped into my command, and because I'm taking value from pipeline by property name, the alias will connect to the name property on the incoming object, and that will work. Except in AD case, the commandlets are weird in the way that they write objects to the pipeline. Now, I could switch things around. In this example here, I'm going to use name and then an alias of computer name. So given that, a command like this should work. Oops, back up here. Get AD computer where the name is like SRV star, back it up, and then that does seem to work because I use name as opposed to computer name. That's kind of not too happy about that. I'd rather have computer name because that's really the standard parameter. But the alias does offer flexibility. If I have a CSV file, as I do here, and I have found, let's try this, in a Jupyter notebook. There we go. You have to, I think if I add the out host, then that gets the results formatted nicely. So that now, as a CSV, has a computer name parameter. And even though I've got computer name as the alias, let's do this out. Because even though the data doesn't have name, it has computer name, so the alias works, as I was trying to explain earlier, using Active Directory. Now, another way around this, and this is why we have these things, would be a parameter set. This is another way of giving the user an option. Yes, this requires a little more work on your part, but it makes the command a little richer and easier to work with. And then I just lost my spot here. Oh, there we go. So maybe the user is going to, I'm giving them two ways to use Backup AD Computer. They can either do it by the computer name, and I'll default to the local computer name, or I'll allow them to pipe in an actual AD Computer object. So if they run get AD Computer, filter, whatever, and pipe to my function, then this parameter set will work. Otherwise, if they were to say import a CSV or manually do backup AD computer dash computer name or dash name or dash CN, they gave that as another alias, then they could just specify a single value. So now I'm setting up the user for success and giving them options as to multiple ways they could use this, whatever really works for them in the best manner possible. So if they use the by AD computer, then all I'm doing in my code is grabbing the AD computer.name and making that the computer name, and then I can use $computer name in the rest of my code. So when I look at the syntax for that new command, the user would see they can specify a computer name, or they can specify an AD computer object. So here's some examples of what that would look like. So I can filter, or I can import a CSV, filtering out the clients and just backing up the servers, and then it works the way that I want it to. So think about who's going to run the code, what scenarios might they want to use, what can you add value-wise to your function that will make it streamlined and easy and effortlessly, or maybe even enjoyable for the user to run. All right, so we've talked about input. Let's talk about execution. When your code is running, consider ways to give the user meaningful feedback. I'm a big believer in using write verbose and occasionally write debug to provide additional information. When I write my code, my function, and you'll see this all over my GitHub repo, I use write verbose statements liberally, and I put them in from the very beginning. They cost you nothing, but they add a great deal of value. And I've also now started using write information to capture process and data information that I can then look at later. So your advanced users that run your code and are trying to troubleshoot something, or if you are developing your code, and this has helped me a great deal, I may have a function that is going to get some information, say from running a REST API. I can use write information and write the raw data to the information stream. Then after I'm done running my command, and if I save the information variable, then I can work with that and kind of see, okay, this is the information that I want. How am I going to get it there? So it helps with my code execution, or I'm sorry, code development, by having those additional streams of information, whether it be verbose, debug, or write information. So let me give you an example here of how this kind of works. I have a module that I wrote for Blue Sky that allows you to interact with Blue Sky in PowerShell. The PS Blue Sky is the name of the module. I'm just going to load my local version here and start a Blue Sky session. And I may have to do this this may not work in my notebook. All right, so now I have a Blue Sky session. And let's do Blue Sky. I'm gonna get my profile. Oh, yeah, let's do. So in my Blue Sky module, information variable. So in my module, I actually wrote a custom verbose function that still writes to the verbose stream, but it includes information with a timestamp, the script block that I'm in, whether it's begin, process, or end, the command, and you can see I'm using PS style to format it. So my verbose messages also include additional information, such as it shows me the version that I'm running under PowerShell. It shows me what host I'm running under, what version of the operating system I might be using, the version of the module. And the reason this might become important to you, the example I always give is, let's say you write a function and you put in, this kind of detailed information, this verbose information. You give it to the help desk. They run your command and say, oh, this doesn't work. You suck. You don't know what you're doing. Say, chill. Open up, do start transcript, run the command, do dash verbose, run the command exactly the way you did, just add dash verbose, let it error out, stop transcript, send me the transcript. I can then look at the verbose messaging and see, oh, they're running version, PowerShell 7.2, and I'm using a feature that was available in 7.4. That's why this doesn't work. So I either need to adjust my code or tell the user to update. But the verbose feedback gives me something to work with. And the information variables, so there's V, and I'm collecting actually quite a bit here. So like first one, I think, is message data. So that's a Blue Sky object that I get back from the API that I can then use to troubleshoot. Oh, and if you want to see what the profile, so there's my profile. The image display does not work in VS Code. And what I've done here in the function, if you want to see the function itself here. So my verbose messages, I'm also using, in this case, localized strings to keep things easier. And for example, here's my write information where I'm writing the response header as an information. And you can look at the code up on GitHub as well in the Blue Sky module. So when the person runs a command, give them feedback. If you have a long-running command, you should learn how to use write progress. Don't be using write host other than 1 or 2 lines. If something's going to have a lot of things going on, learn how to use write progress and not write host. So, okay, so we got input, execution. Now let's talk about output and objects. Like input, it's impossible for you to know all the ways that someone might take the output of your code and use it. Don't assume that they're just going to look at it on the screen. They may think of a way or want a way to use it that you never even dreamed of. But you should still try to anticipate, likely scenarios. If they're way off base, then there's nothing you can necessarily do about that except be in a position to take feedback and say, hey, I need to be able to take the output and do X with it. And then you can help them figure out, okay, how do we accomplish that? When you are writing, assuming you're writing objects to the pipeline, you should write the richest object possible. Again, this comes back to, do your job as a PowerShell scripter. Don't make the user suffer or work because you aren't providing them the information. Don't make it easy and say, oh yeah, I only need properties X, Y, and Z. If there are properties ABC, X, Y, and Z, give them ABC as well. But important, separate the formatting from the output. You should never have format commands inside your function. Because again, you don't know, maybe they want to see this as a list. Maybe they want to see it as a table. Maybe they want to see properties formatted a certain way. So let's look at this idea here. So here is a very basic function that's going to query the Aaron REST API and give me information, basically who is information on an IP address. So let me run this, and I need to fix this. Let's do out host. So now you can see the results. Okay, so I have IP, the name, and the registered organization. And you may think, okay, I'm good. That's all I need. I'm done. But if you were to go back and look at the actual JSON data that you get back, there is a lot more information that you're leaving on the table, that you're not providing to the user. Because maybe all you want when they run the command is to see the IP, the name, and the registered organization. And that's fine, but we can handle, that's formatting. That's why I'm saying separate the formatting from the data. Give the user the richest data that you can. We can worry about how to format it and present a default view later. So here is my revise function that writes a richer object to the pipeline. You can see I'm getting other information from my data. Let's update this to use outpost. So now when the user runs resolve who is, and they give an IP address, by default, and unfortunately, I don't know why this turns yellow in the notebook. But you can see there are other properties there. If I highlight it, you can see. So now I have a rich object because maybe the user, especially if they're feeding multiple IP addresses, they can then filter, build a table, do whatever they want. If I need to give the user a default view, then I can use a number of tools and create a custom format.ps1 XML file. You just have to make sure that your custom object has a unique type name. I typically use PS custom object and just add the PS type name parameter or key in the hash table, and then the value that will become the type name. And I can use that to build my custom formatting or other type extensions. So let's look at a more practical example here. So this is a function that writes an object of the pipeline that will work. It's not ideal in this current state here. So this is going to go through a given path and return information about all of the different file extensions and show me the extension, the total size, the smallest size, the average size. Let's see if this will cooperate. So this is using whatever my current directory is, which I think is the directory where this notebook file is. So that's not too bad. But the path isn't, because I just used a dot. I don't really know what path that is. The data is not necessarily formatted nice for me. So let's make a more human-centered version. Again, in terms of mechanics and stuff, this works, but it's not very human-friendly. It's not human-focused or centered. So let's look at this version and see where I've added some values. So I've added an alias. I have an output type. The output type that you put here is purely documentation. It has no effect on PowerShell itself except for the automatically generated help. Notice my use of the help message on the parameters. The user may never see these unless they are using generated help. They will be used if I use platypus to generate help for this function. They'll be used there. They also serve as documentation for anyone who has to manage this code later. They can go through and say, oh, recurse parameter. Oh, it's going to recurse through all subdirectories. So it's useful information to include, even if the user isn't necessarily seeing it. The person maintaining it might find it useful. So I have some right verbose lines where I'm showing the command I'm running, what version. In this case, I add a little version to the function itself. I'm running under PowerShell version, get the version table using the host. I'm going to recurse. I have write information. And after I go through and search everything, so here's my custom object. Look how much richer this is. So I give it a file name. I'm using some math to round this to 2 decimal places for the percent. The total size is just the sum. Now, I'm not formatting. This value will be in bytes. If I want it in megabytes or something, that is formatting. I can handle that separately, which I'll show you in just a second. Minimum, maximum. Now, I'm adding additional information. My output from doing the file listing doesn't include the computer name, but maybe I might be, or the user might save this information to a JSON file or CSV file. And then if it just says computer name localhost, and I look at that information later, I have no way of knowing what machine was this on. So I'd like including things like computer name. I might even include something like the report date. When was this run? Again, if I'm serializing this and I look at it later, how do I know if this information is still relatively valid? Is it extremely old? Is it fresh? So I'm adding value in the output for the person who's going to run this code so that they have meaningful output that they can use. So let's load that function. Let's see if this will work here. So let's run this on my presentations folder. So there's all my verbose messaging going on. And if I did this right, no, it did not. It did not save it to the variable $R. I will um, so there is the object, and you can see there's the path, the extension, the sizes, and all of that. But let's make it even more human-centered. I can add, for example, an alias property. So instead of forcing the user to use total size, they can just use total. And I also have a custom formatting file that they can use. So I'm going to try this one more time. No, I need to. Actually have a version. Oh, I have a version already loaded that I can, if I can get to my samples folder. We'll just run this again real quickly. So there's the verbose messaging. And this is my default formatting. So my formatting includes output that shows me the path and the computer name. It shows me the extension, the count. The sizes are not formatted. There is a property to say, hey, is this the largest file extension? And if it is, in my format file, I'm displaying it in this little magenta color. But I've given now the user output. Now, this is just the formatted output. If I do $R, I still have all of the values there. And if I wanted to, I could create my own formatting and say, yep, do this and show me the smallest size in megabytes or kilobytes or whatever you wanted to do. I could also, I don't know if I did it here. Oh, I can see if I defined any additional views. No, all I have is the default view. I could have created additional views in the formatting to display the information in a different format. So let me keep going here. Oh, yeah, there is a view total MB. Oh, there it is. I don't know why I didn't see that before. All right, so there's my alternate view. And if I do this, yeah. Things about alternate views is they're not easily to discover, so you'd want to document that to make it easy for the user. I would include an example of this in the help for this command, so they would be able to see that. And if I wanted to, I could let the user, if they want to convert to JSON, they could easily grab whatever properties they want because I've given them something rich to work with. But what you need to think about as we're going even further, other things that you could look at and things that you want to think about. What would make it easier for the user to provide input parameters? Do you want to provide a GUI interface, for example? Do you need to include aliases? How can you optimize the output of your command for maximum value? Not only what you think this looks nice, but what does the user want? And what might they want in the future? Because if they're going to want it in the future, just put it in now and be done with it. Don't worry if you're presenting too much information. If you think, oh, this is too big an object for the user to see, that's when you create the custom formatting files and create a default view. But don't limit yourself. Don't limit the user just because you don't want to show, an object with 50 properties. Get process is a great example. Process objects have a ton of properties, but we have a default view that shows them in a way that is convenient and meaningful to the typical user. But if I want to use that information in another way, I have access to all those properties. Things that, again, will make your code maybe easier for someone to use are property sets. If you are doing something, for example, with a function that's going to use a SIM, to use get SIM instance to query information from a remote computer, maybe you want to give them a parameter set for a computer name and another parameter set to specify an existing SIM object. That way you give them some flexibility as to how they can use your code. We'll talk about additional formatted views, a type extension, something I didn't really get a chance to talk about at all. When you were creating a custom object, and certainly like when you're creating classes, you don't have to define everything in the class or in the custom object. There may be some things that you want to add outside of that, such as an alias property or a script property, or if you really need to, a script method. But you can define those as type extensions outside of your code. And then lastly, when you're writing functions and writing things in PowerShell, I like to encourage people to think locally, but act globally. Think about if I run my command here to get the file extension info. This is written to be run locally and because it uses a local path. But if I wanted to run this on a remote server, I how would that affect how I write this code? I or, yeah, I'm just going to leave it at that. So think about, yes, I'm running this, but if I want to be able to run this remotely on 50 client machines, I want to check their user home directory or something, and I'm going to use remoting to do that. How can I do that in the command and make it as seamless and as easy as possible? Now, there may be one command, maybe that might be a couple commands, but you have to think about how you might want to orchestrate that and think about how can I make life easier for myself or the admin, whoever might be using this, to get that information from all of the remote machines. So let me give you my summary and then we'll answer some questions here if you have any. So again, consider who will be using the PowerShell code and how they will be using it. How they might use it, how might they want to use it now as well as in the future, and might have to consider some edge cases. But don't get too hung up on that. You should be able to focus on the 80%. But if there is something that's going to be on an edge, give the user a way to let you know, hey, I need to be able to do X, or I need some help with this. Big thing here for me is always telling students, don't assume. Don't assume that the user knows what you know. Don't assume that they're going to use the command and enter values the way that you use it, that they're going to use the output the way that you use it or that you had in mind when you wrote it. So that's where error handling and validation and aliases and parameter sets, all those things, that's where that comes into play. That's why we do those things, because we can't assume that the person's going to run the code perfectly the way that I do every time when I developed it. And of course, PowerShell obviously is all about the object. You want to create rich, meaningful objects to the pipeline. Formatting is separate. Just give the user as much information as you think they might possibly want to use. If you want to format it to make it easier to read, or provide things like property sets to say, hey, I want to get these set of properties, and that's when you add that. That's when you do your job as a PowerShell scripter. Write PowerShell tools that are elegant, effortless, and efficient for the user, not for you, but for the user. You need to design your command with the people who are going to run that code in mind. We're not generating code. PowerShell scripting really is a craft, or I think it should be. You want to craft your PowerShell code for not only the person who's using it, but for the next person who has to maintain it, which obviously could be you in 6 months. So that is, well, we even got in under time, despite my crash and setting things up here to go. So are there